Okay, got everything wired up and finished, you know that, so time to set the machine up, make sure everything is working, and so that I don't look like a damn fool. I already did some setup, a little bit of the setup anyway, just to make sure that the motors move and you know, everything's working in that way, but I'm going to go through it in the video anyway. There's some basic stuff that we need to set up in hardware so that the computer and Mach 3, this is Mach 3 by the way if you've never seen it before, so that the computer through the printer port can talk to the 5-axis controller that I have installed in the box here. And recall that 5-axis controller controls the 3 stepper motor drivers, and so we need to configure it. We need to configure Mach 3 so that it knows what it's talking to on this controller card. And so the first thing we're going to do here is we're going to start at the very beginning. There's a config tab up here on top of the screen. We're going to very first thing we're going to do is select native units. Now I'm going to forewarn you, everything I'm doing here is in inches, okay? So if you use millimeters, then I don't know, I'm not sure how well this will translate over to that. It might be a little confusing for you, but everything here is done in inches. So we're going to select native units as inches, and now we're going to go to the second tab down, or not tab, but the second selection down is ports and pins. I'm going to select that. First thing we're going to do here, well, I'll just say this about that. The default it comes up with is the port setup axis selection tab here. This is the printer port address, okay? Right here, it comes up default, port enabled, port number 1. This is the computer port, okay? The printer port in the computer, and that's the address it uses. 99.9% of computers of this era, okay, that use the parallel printer port use that address, 378, hex 378. I've never come across a computer that didn't, but in the event that you have problems in the future and you can't get your computer to talk to the Mach 3 controller, you can get into Device Manager, look at your LPT1 COM port, open up the Properties box, and you can verify that the address is set at the parallel port is using this address, hex 378. One other warning I wish to warn you about. Guys fall into this trap all the time, and I fell into it too. You go out and you buy an old used computer, what you think is an old used computer, and you buy one that's a 64-bit, not a 32-bit, but a 64-bit machine, Windows machine, and you think, well, that's okay. Well, it's not okay, because Mach 3 will not work on a 64-bit machine. The printer port will not work. So you'll get your screen set up, you'll get everything will show up on the screen, but when it comes to talking to your hardware, it will not work. So don't fall into that trap. Make sure that when you buy an old used computer, I just picked this one up a few weeks ago, make sure that it is a 32-bit machine running Windows. Now it can be running XP, it could be running Win 7. I think it probably is even okay with Win 10 if you can get a 32-bit machine to run Win 10, but anything from XP to 7 I know will work, okay? So we're going to go off this, we're not going to close this down yet. We got another tab here now that we're going to set up. Remember, we're configuring hardware now. So we're going to click on the motor outputs tab. That's sort of a misnomer, by the way, when it says motor outputs. It's not we're not setting the motor outputs, we're setting the printer port here in the computer to talk to this card. And this card indirectly controls the motors, okay? So we're going to be setting up port pins. These things are set to port pins. You can see the X, Y, and Z axis, and even though I have an A axis, I'm not going to set it up, okay? Just to keep this simple, most guys only have 3 axes. Note that I have them enabled. Gotta have them enabled. If you're going to use them, you have to enable them. Now, what I'm enabling here, okay, is the output of the printer port, computer printer port, to talk to the input of the 5-axis controller, okay? And you can see I already have pin numbers in here. Now, let's just jump over to the other side of the screen for a second here and just talk about this. You see, step port, direction port. These should always be 1, because in this system and in 99% of the systems out there that, you know, you're running a mill, or like my router or my CNC laser machine, they only have 1 card installed, 1 axis, 5-axis controller, 6-axis, 4-axis, 3-axis, whatever it might be, but there's only 1 port, okay, and that's port 1. So it should always be set or default to port 1. Now we've got X, Y, and Z enabled, and what we're going to do is we're going to assign the pins in Mach 3 so that it knows what to output to on the printer port. And where do I get that information? Well, I get it from here. Turn the page over. This is my controller card. Bought it on eBay. It cost like $7. Dirt cheap, unbelievably cheap. But you can see the pins, the signals, and the port pins are identified here. Okay. Now, for the X-axis, we've got what they call a step pin and a direction pin. And just forewarning you guys, I don't want to make this too complicated, okay, but these people mix up terminology all the time. Here they call something a step pin. Here it's called pulse. This is the card, the driver card. I can get it in focus. I can't seem to get it in focus there, but here they call it pulse. It's the 3rd signal. No, 2nd signal there, see it? Pulse. And yet somewhere else they call it something else. Here it's step. No, here it's pulse. Okay, so here it's pulse. Sometimes it's called clock. Sometimes it's called pulse. Sometimes it's just called step. Step clock is really the long name for it. Okay, don't get confused by that. So what we're going to do is, you see I got 2 pins assigned here already, and all you have to do is click on this and enter a pin number. Okay, it's always going to be port 1, and the X step pin or clock pin is on pin 2, and where did I get that from? I got it from here. See it? Very first signal here. X pulse is the same as step, is the same as a clock. It's on pin 2. The direction is on pin 3. And so for the X, I've got it populated already. It's pin 2 and pin 3. Now the direction, signal, and the polarity, these are polarities, by the way, okay? It says direction active low, or direction low active, step low active. This is designating the polarity of the signal. I always set them active low, okay? Because the way I wired up my hardware is I used a common anode configuration for the card. All of these signals here, you can see they're optically isolated. Oh, I got bad lighting on. You know, this thing is black and it's hard to... There you go. You can see the anode of all those opto-isolators are tied to 5 volts in my system. All 3 of them. A daisy chain. Enable, pulse, and direction. All the anodes are tied together to 5 volts. That's why I use an active low signal, because when I want the signal, I want it to be active low to turn on the LED. So I always check off all of these, okay, to make them active low. Note that I've got one that's not active low, and that's because I told you I've already done some of this. But the direction signal, polarity, you can use to reverse a motor on an axis that's not going in the right direction. Okay, and that's what I did. I found my y-axis to be going opposite of what I wanted it. And so I got back into this menu and I changed the direction signal to an active high. This is... Again, this is, you know, it's almost against convention, you know, but the X means it's active high. A check mark means it's active low. So anyway, I switched it to active high, and that switched the X-axis into the direction to make it jog into the direction I wanted it. The Z-axis, same thing, I enabled it. I got the 2 pins off of this. The Z-axis 6 and 7. You see Z-axis here. And the pulse, which is the clock or the step. Pin 6, pin 7, okay? And ignore the A-axis, it's disabled right now. I must have been using this for something else at one time. It's got some pin numbers in it. I use the same program, by the way, for all my machines. So when I start populating some of these tables, they may have pin numbers in them because I set them up for other machines before. I just make a new profile for a different machine. Okay, so we're all set up here. We got the X-axis enabled, the Y-axis enabled, and the Z-axis enabled. And we've got the proper port pins outputting the signal, and these should all be checked off for active low. So all the signals are active low, and these should all be pin 1. Port 1, not pin 1, port 1. I'm just going to click apply. Okay? And next we're going to go to the input signals. And these are all the limit switches. I'm sorry, quick brain freeze there. Same deal here. It's almost intuitive. You're going to use a switch, you check it. I've got 2 switches on the X-axis, 2 switches are enabled, and I'm going to use one of these 2 switches shared as a home switch. That's going to be checked off. Again, a Y, I've got 2 switches, and I'm going to use share 1 switch as a home switch. And the Z, I only have 1 switch wired up on the column here. And I'm also going to use that same switch as a home switch. Okay? They're all on port 1, okay? Like I said, this is the only port we got here. So. And now we're just going to populate these fields with the pin numbers. And where do I get it? Again, I get it from the card here. They do have an automated setup here, but it's hardly worth going through it because it's so simple. All you have to do is fill the pin numbers in here. And there's only 3 axes. There's only 3 pin numbers you have to fill in. So let's do the X. X limit. X limit is pin 12, okay? And the same pin is used for all of these. Okay, 12. All the X. 12 and 12. And I'll explain that in a little while, okay? Now the Y, again, let's see, where's the Y, is 13. Okay, Y limit switch is 13. And so we have 13, 13, and 13, and the Z limit is 15, pin 15, okay, 15. Now these pin numbers correspond to a port pin. I mean, these are input ports on this controller card, okay? Alright, now 15, and the home switch uses 15. Remember, so some of these switches are going to be shared, and I'm going to try to explain that without confusing the hell out of everyone in a minute here. By the way, I filled in all this stuff before, and when I came back into the screen, it was all zeroed out, and I'll tell you why, because I forgot to hit the apply button. So make sure you hit the apply button, because nothing gets saved unless you do. There you go, apply, okay? Now, here's a concept, might be a little confusing. There's a single port, okay? Note that says XYZ. They only show one switch here. That's just, how would you say, simplified representation, okay? The fact is that most people, I'd say 99% of people, use two switches for the X and two switches for the Y, and they're wired in series, okay? And through normally closed contacts, which means that if either switch gets bumped by a cam on an access, it will open. And when the switch opens, the signal at the card, and you know, for you guys that are electrically challenged, I hope this doesn't confuse you, but the open is recognized as a logic 1. It actually goes to 5 volts because there's a pull-up on the card in the port. So my switches are normally closed unless they are contacted by a cam, okay? So we've got an X limit and a Y limit switch. How does Mach 3 know which one got hit, which one didn't? Well, Mach 3 in the background monitors table direction, okay? And so when it hits the X limit switch here, it knows where that switch is physically on the table. Same with the Y minus extreme. And the reason they monitor the direction that the table was moving is because most systems that are wired up, okay, note there's no special wiring for a home switch here, okay. They'll limit, they say limit on them, but you can use them as home switches too. Mach 3 in the background, in knowing the direction the table's moving, and in knowing that this X switch, this one, is shared as a home switch, okay, it knows the difference. It knows that when you're jogging the table in that direction, or a program goes awry because you didn't write it correctly, and the motor's running and it's going towards that X limit switch, unless told otherwise, it treats it as a limit switch. That's a default, okay? So it's there to limit movement and stop the motor in the event that something goes awry. However, when you are in the Mach 3 home screen here, okay, this is the exception. This is how it treats this switch differently when you hit this reference all home button here. See it on the side? When you click that button, Mach 3 knows to drive the motor in the direction of this switch and to treat it as a home switch. That's how it differentiates between whether it's a limit switch or a home switch. It does it in software, so hopefully you got that straight in your head. Okay, so physically this switch is one switch and it has two functions depending upon whether or not you hit this reference all home button. If you don't touch that button and you're running a program in Mach 3, which we'll look at later, but you're running an automated program, something goes awry, which happens a lot, by the way. You wrote something wrong in the program, you accidentally clicked the button, whatever might have happened, and the machine's running away on you, and suddenly you're in a panic, okay? Because you know it's going to hit that hard stop. Well, the limit switch will stop the motor, okay? That's its primary purpose. Secondary is the reference all home. All right, now that we got that out of the way. Okay, I had to do a little editing here because we're not done with this screen. I forgot about, there's one signal here that you need to set up beyond the limit switches here. Another input. And that is the e-stop signal. And we're going to scroll down and find it here. It's right here, e-stop. You can see it's enabled. E-stop means emergency stop, by the way. And that's an input that would be monitoring an emergency stop button. Now on the Harbor Freight mill, it has an emergency stop button. That's the power button. Right here, okay, but hitting that button, well, that button, let me just say this, that button is not wired into the electronics, because they sell this mill, it's not a CNC mill from the factory, so there's no interface between that emergency stop button and the 5-axis controller, okay, so hitting that button shuts off all the power to the mill and the mill motor, but doesn't do anything to the electronics in the electronic bay. So back to this. This e-stop signal since it's not wired up and there's no interface to it, this e-stop signal has to be dealt with. Now, it defaults to enable. You see it right here? I didn't select it. I didn't enable it. It defaults to enable. Mach 3 does that automatically. And there's a problem with that. And I'll show you. You see the reset button here? I'm going to close this for a minute. See the reset button's flashing here? You see, I can't reset. As long as it's flashing, it's in the reset position and I won't be able to reset it. And that's because that e-stop signal is active. And it's looking for me to satisfy it, with an external e-stop button, but there is no e-stop interface to the card. So what we have to do is disable that signal. So we're going to go back to config here, and ports and pins. We're going to look at that signal again, input signals, and we're going to take the slider and go on down to e-stop. You can see it's enabled. Now the first thing I did, and most people do, is they try to disable it like this, okay, and click apply and OK. But you still can't reset. And that's because Mach 3 will not allow you to turn that signal off. Okay? So Mach 3 enables it, and if you try to disable it, it won't allow you to disable it. Okay? So what to do, what to do. There's a little trick here. Okay? Go back to ports and pins and input signals. And what we're going to do is full Mach 3. into believing that that signal is not on port 1, but port 0. There is no port 0, okay? But in remapping the port output, it fools Mach 3 into believing that it should be monitoring port 0. There is no port 0, so we'll click apply here. And OK. And we should be able to reset. And we do. See, the reset's not flashing now. I had to do this little bit of editing to get that in there. And so we're good now with that. What else do we have to do here? We've got one output signal to set up. And I'm going to show you that. Where did I get that from? Again, from the card. In hardware, in the system, okay, on each driver has an enable signal. Okay, you see it's the third signal over. It says EN on it. Again, it's common anode, so the anode is tied to 5 volts. This is the only signal that is common to all driver cards, okay, the enable signal. The pulse and the clock, the direction and the clock signals are unique to each driver, as we've seen here. But the enable is daisy chained. So when the enable goes active in the system, it enables all 3 cards if you have 3-axis, or 4 cards if you have 4-axis, like I'm going to have. But it's a single signal, okay? It's one signal that enables all 4 cards. And it's an output signal of Mach 3. So it's enable 1, port 1 again, you know that the card is port 1, this is port 1. And we look for enable on here, and you'll find it's PID 14. See it? That's where I got that information from. And so it's there, and I set it up already, and I'm just going to click OK. And we're done here for now.